Hello, Coach Holmes here, and today we're going to be talking about interior angles in a polygon. First off, we need to talk about what a polygon is. Polygons are any closed figure with no curves. So they're all straight lines that goes around all the way around, touching each corner. Alright, now we want to talk about each polygon as far as like what each of them are. So for example, a three-sided figure, we know that to be a triangle. So and a four-sided figure, more often than not, you kind of hear rectangles and squares, but by pure definition, they're quadrilaterals. A five-sided figure is called a pentagon. A six-sided figure is a hexagon. A seven-sided figure, you probably never heard of this, but it's called a heptagon. And an eight-sided figure is a octagon. Now, they all have a specific pattern that is going by as far as interior angles. So for example, we know that the total angle of a triangle is 180. Quadrilateral is 360, but we don't necessarily know the rest. But the pattern that it happens to go by, if we were to measure each figure, is that it's going up by 180. So for example, if I add 180 to 360, just gives me 540. And I can just keep adding 180 from here. Now give me 720. 720 plus 180 is 900. 900 plus 180 is 1080. Now, anything past 8 is an n-gon, which basically means however many number of sides you have, it's a 12-gon. Like if you have a 12-sided figure, it's a 12-gon. A 14-sided figure is a 14-gon. And that's just dependent on the number of sides. Now the formula for it, how we determine it, it's simply 180 times n minus 2. That's how we're going to be able to figure out the total interior angles of a polygon. So if we're looking for a 9-gon, a 9-sided figure, all we got to do is say that n is equal to 9, and then plug 9 into n. So if I do, I'm just going to write the formula real quick. So I'll replace n with 9 to make it 9 times 2. 9 times 2 gives me 7. And that's going to give me 1260. Okay? So a 9-sided figure has the total measured length of 1260 of angles. Now, how about to find a regular polygon? So if I want to find a regular polygon, which basically means that all the sides and all the angles are equal to each other. So how do I be able to find that? Well, the formula basically states that it's 180 times n minus 2, all that over n, which is the number of sides. And the reason why I can say that is because if we know what the total length or the total angle of it, and we got to divide that evenly by however many sides we have. That's how we know we get this formula. So for example, if I'm looking for a pentagon, like the angle of a regular pentagon, remember, all I gotta do is say, which remember, That's 5 sides. So what we gotta do is 180 times 5 minus 2 over 5. Which we know that to be 180 times 3 over 5. That's 540 divided by 5. And that gives me 108. So 108 degrees is the angle for each pentagon, for each angle of a pentagon. Let me repeat that. Each angle of a regular pentagon is 105 degrees, right? That's how we were able to determine. Now, another interesting fact is exterior angles. And this is just kind of interesting because no matter what polygon you have, no matter what, the sum of the exterior angles from each vertex is 360 degrees. So I'm just gonna rewrite this real quick because my writing seems sloppy. There we go. There we go. So no matter what, the sum of each angle that is outside of the polygon adds up to 360. All of them. They all add up to 360. So for example, if I look at this, I know 180 minus 70 is 110 minus 50, that gives me 60 degrees. So I have figured out the angle for each one. So 180 minus 50 is 130. 180 minus 70 is 110. And 180 minus 60 is 120. And this is just to show y'all how it works. So if I add 120 from 110 and 130, I end up getting 360. And I can do the same thing when it comes to a quadrilateral, a pentagon, an octagon, a 20gon, whatever the case may be. All the exterior angles adds up to 360. Okay? Now, how about when it comes to finding interior angles? Let's talk about that. Let's talk about finding interior angles, especially for each one. So notice here, got 2x, 2x, and x and x. All four different values. All right? And I want to be able to find the angles. So what I want to be able to do is add them up. Add these up and set it equal to 360 because that's the total angle of a quadrilateral. Now, 2x plus 2x is 4x, plus an x is 5x, plus another x is 6x. So if I add all these together, that gives me 60. All right, now divide 6 by to both sides, x equals 60. So I know that this x has to be 60, this x has to be 60, and 2 times 60 gives me 120. All right, that's how we're going to be able to find the angle for each one. Now, next we have a hexagon. Now, we know the total length of a hexagon happens to be 720. Now, if I add all these up, I should be able to solve for x. But to make it simpler, because I know that these four are the same, these two are the same, I'm just going to say 2 times 2x because there's two 2x's plus 4 times 9x plus 30 because there's 4 of them. Just to make it simple and easy. So 2 times 2 is 4x. I got to distribute the 4 to make it 36x plus 120 equals 270. So now, combine like terms, so that's 4 plus 36, which is 40x. Subtract 120 from both sides. 0, 0, 6. So I have 40x. I want to divide by 40 to both sides. X is going to give me 15. So now each x is 15. So 2 times 15 gives me 30. So for each 2x is 30. And then 9 times 15 plus 30 is 165. Good grief. So each of these 9x plus 30 is 165 degrees. So the biggest thing we got to be able to, excuse me, the biggest thing we got to be able to remember is that for each polygon to find the interior angle, it's 180 times n minus 2. That's how we get interior angles. Now, in order to get exterior angles, they all add up to 360. Thank you and have a good day.